Today we're going to start talking about factors, and today also the greatest common factor of numbers. So first, remember, prime number has exactly two factors, one in itself. And if it's not prime, it's most likely composite. It has more than two factors. There are two exceptions to those rules. 0 and 1 are neither prime nor composite. Prime factorization means you want to find numbers that are prime numbers that multiply together to give you another number. Usually what most people do to do this is make a factor tree. So it doesn't really matter what you start with, you just are done when you get to prime numbers. So I can start with 9 times 10. If you want to start with 3 times 30, you can. Is 9 a prime number? No, it breaks down into 3 times 3. Is 10 a prime number? No, it breaks down into 2 times 5. 3 a prime number? Yes. 2 and 5? Yes. I like to write these. You can write them either in, I like to write them with the smallest first. 2 times 3 times 3 times 5, that's called factor form, or 2 times 3 to the second times 5. As long as it doesn't specify in the directions, I don't care which way you write it. If you do have a negative in front of it first, think of just factoring out a negative 1. Negative 140 is the same as negative 1 times 140, and then go from there. Again, you can start different ways. I'm going to start with 14 times 10. You might start with something different. 14 is not prime. 2 times 7, those are both prime. 2 times 5. So my answer would be negative 1 times 2 to the second times 5 times 7. So that's prime factorization. Make a tree. Next thing we're talking about is just finding factors, or factoring the number. So we want to come up with prime numbers that factor together to give you 12. So you can make a tree for 12 if you need to. Sometimes we'll be able to do some of these easier numbers in your head. 4 times 3, so it is then 2 times 2 times 3. I'm going to write that out as 2 times 2 times 3 because it wants factors. And then just A, and then B, B, B. So that would be factoring that. To find all factors of 40, that means just not prime factors, so numbers that multiply together to give you 40. So I just start at the beginning, 1 and 40. I like to put it down at this end. 2 goes into 40, 20. 3 go into 40, no. 4 times 10, 5, yes, 5 and 8. 6, no. 7, no, and then you start overlapping. So be careful and think of that. You might use some of your divisibility tests, if you remember those, on how to use that. Now we're going to find the greatest common factor. Let's remember what that means. Greatest common factor. The biggest number, and factors are what go into the numbers. What's it called if they go into a multiple? So these are greatest common factor. So you probably should make a tree for each one. And again, you might not have to make a tree all the way. You know, this 24 is 8 times 3, and 8 is 2 times 2 times 2 times 3. 36 is 6 times 6, and each 6 is a 2 and a 3. So 2 times 2 times 3 times 3. Just be careful if you're not going to make a tree. So now we're going to use that word common. They have to be in common. So I'm going to pair them up. I have a group of 2s, I have a group of 2s, and I have a group of 3s. Doesn't really matter. I could circle this 3 or this 2 with that. Doesn't matter. You take one out of each group, a group of 2s, a group of 2s, and a group of 3s, and you multiply them together. 4 times 3 is 12. And some of you probably knew that ahead of time, okay? But when you get into bigger numbers, this is a process you can go through. Prime factorization of 15 is 3 times 5, and 16 is 2 times 2 times 2 times 2. What do they have in common? Well, nothing to circle, but what does everything have in common? 1. So here the greatest common factor is 1, and this has a special name, relatively prime. So relatively prime when the GCF is 1. Say we want to find the GCF here. Well, 36 we just did is 2. Whoops, sorry. Forgot. So 36 is 2 times 2 times 3 times 3, and then we have x, x, y. 54, if you remember, is 6 times 9, so that's going to give us a 2, and then a 3, and then another 3, and another 3. X, y, y, z. So now we're circling things in common. We have a group of 2s. We have a group of 3s, we have another group of 3s, a group of x's, a group of y's. So 2 times 3 times 3 times x times y. You do need to simplify this, okay? So 6 times 3 would be 18xy, and if this would have been another x, it would have been x squared, so actually go ahead and multiply it out.